Hello everyone, my name is Ryan Myers and I will be presenting my research project on the Ford Motor Company. This presentation will cover the main analytical findings of the research project, as well as background of the Ford Motor Company and best practices when it comes to data analytics. The objectives of the research are to identify trends in the automobile industry. The automobile industry is a constantly changing environment where product demand is driven by consumer need as well as regulatory requirements. So the research's main objective will be to identify the present and future state of the industry, focusing on two key areas, and that is gas mileage ratings and vehicle types. The research will compare the Ford Motor Company to the industry in regards to these two main areas through visual and statistical analysis. The second objective is finding areas of future growth in the industry. This includes new technologies and different trends that are being seen within the industry. These will be explored in the data exploration and descriptive statistical analysis. The deliverables are the project to provide models and analysis that will give Ford Motor Company a competitive advantage. The changing market will require robust models as well as predicting future values for key areas. We will now go into the background on the Ford Motor Company. Ford Motor Company was founded in 1903 and is headquartered currently in Dearborn, Michigan. From the very meek beginnings that it saw, it has grown to 125 locations globally and has 186,000 employees on a global level with 88,000 U.S. employees. This makes the Ford Motor Company a prime candidate for doing an analytical project on a U.S.-based corporation. Ford has seen this increase due to many popular inventions and products such as the Model T and the creation of the first moving assembly line. Ford Motor Company is currently the largest U.S.-based automobile manufacturer and the fourth largest automobile manufacturer in the world. It has $127.1 billion in annual revenue as of 2021, making it one of the Fortune 500 companies. This revenue is generated by the many product offerings offered under the names of Ford, Lincoln, and Troller. Now that we have background on the research project as well as Ford Motor Company, I will describe the dataset that will be used for the analysis. The dataset that's going to be used is provided from the Environmental Protection Agency, or the EPA, and is called the Trends Database Research, or Dataset. The data gathered in this dataset is from 1975 to the current completed year, which at the time of the study is 2020. The variables included in the dataset are all on automobiles and include variables such as model year, vehicle type, production share, real-world miles per gallon, and CO2 emissions. The dataset is used from a comma-separated file that is stored on the federal government EPA.gov website and is used through Excel to import into the coding environments. The supplemental datasets that will be used are from the Department of Energy. These are publicly available datasets on the top vehicle manufacturers in the world, as well as the global electrical car market, which will be used for the future analysis of the industry. A visual representation of the data is found in this data dictionary. The data dictionary provides descriptions as well as all the variable names that will be used, as well as the type of data that is used. Many of the data points are numeric, which is perfect for the analysis that's going to be conducted in the research project. This data dictionary can also be referenced if future analysis wants to be completed once the findings are made known from the current study. Now we will talk about the study overview. So the study is to evaluate the current and future state of the automobile market. Different factors have influenced the need for a study such as this, such as environmental, health, and economic factors that have recently been deployed in the United States. The EPA and the National Highway Traffic Safety Administration, or the NHTSA, have released documentation on the fuel economy and greenhouse emissions requirements. This has pushed automobile manufacturers to more tightly look at how they are performing in these areas so that they're not fined or have products that consumers want to buy. There are various different research methods and research projects done on similar type research, such as the gas mileage rating study done by Thomas in 2016, but there has not been any research done that has been driven primarily from a data standpoint. Most of it has been through data and engineering type studies. The study will use both descriptive and predictive statistical modeling techniques to provide a holistic view of the industry in regards to these identified environmental and economic factors. The predictive models will provide Ford Motor Company the ability to predict into the future on these different factors and develop a competitive advantage with viable products. The research hypothesis that will be used throughout this study is what factors have statistically significant impacts on the real-world miles per gallon values for automobiles. This will focus primarily on that EPA data set that will be the primary driving force for the study and as well as the analytical findings. This research hypothesis and study will provide focus to Ford Motor Company on where they should focus their time and resources and allocating to the correct factors that are impacting this area of environmental health and economic factors, primarily in the area of gas mileage ratings. So now that we have an overview of the study, we're going to go into the research design of the project. The research design includes a derived data set, which is the EPA data set. This means that it is historical compiled data that's going to be used to generate new knowledge from this historical data. The main thrust of the project is going to be testing of the null hypotheses, which the null hypotheses are testing if there's any statistically significant relationship between any of the EPA variables and real-world miles per gallon. The goal of research is to ultimately reject the null hypothesis in favor of the alternative hypothesis, which states that there is a statistically significant relationship, where the null hypothesis states that there is no significant relationship between these variables. The data exploration and descriptive statistics of the project will be performed in Python using the Jupyter Notebook distribution. We'll be using the Pandas, the NumPy, and the Matplotlib libraries mainly, which are very popular libraries used in data analytics in the Python programming language. The predictive models will be built in the R programming language using RStudio, which is a free distributed software package for statistical analysis. The models that are going to be built are a multilinear regression model and time series forecasting, or ARMA model. These models will be used for the basis of determining future values of the real-world miles per gallon variable and whether to reject or approve the research null hypothesis. Now that we understand the research design, we will talk about the limitations and ethical considerations. So there are currently some limitations to what can be performed in the research project. The current available dataset, the EPA Trends database, provides a rich data, but is publicly available data, so any internal data to the Ford Motor Company cannot be used. This internal data would provide a more robust model in comparisons, as well as providing a more realistic look as to how Ford is currently poised in the industry. But the analysis that will be done with the EPA Trends database will be useful in determining a framework for the model that can be used by Ford, as well as any ethical considerations, so the 4 elements of data ethics: identity, privacy, reputation, and ownership, defined by Davis and Patterson. These are the main 4 aspects of big data ethics. Since the EPA dataset is from a federal database, it's a regulatory database, meaning that there is no problems as far as identity or privacy, since this is publicly available data and is required to be reported to the federal government per laws and regulations. The data set is also aggregated, so their data cannot be pinpointed to one individual or one individual corporation. It's aggregated in a way that it is an ethical way to use the data. It also provides a framework for the research project, and it will be able to be shared with other different industries. We're going to go now into the data analysis and findings. So as discussed before, the data analysis, exploration, descriptive statistics are done in Python. So the very first area that we want to look at is the response variable of our research. So what we really care about is the real-world mile per gallon ratings. So this chart here shows the trend of the real-world miles per gallon by vehicle types. So the analysis will focus on all vehicle types rather than focusing either on cars or trucks. But as you can see, for both cars, trucks, and all vehicle types, there has been a trend upward overall for real-world mile per gallon by vehicle type. This is important to realize for when we do our analysis, because the model should also have predictive values that are increasing over time rather than decreasing over time. Another area of exploration of the dataset is the trend of production share of vehicle types. So as we can see from this chart here, there has been a change in the different production share of vehicle types. So we're comparing cars to the truck vehicle type. As we would assume, cars would have a higher miles per gallon rating based off the last visual that we saw. But based off the production type and customer demand, somewhere between 2017 and 2018, there has been more production share of trucks than there are cars. This is important to understand when performing the data analytics, because it shows that Ford Motor Company may want to focus on producing trucks rather than cars, but they also have to combat that with the fact that trucks are getting less real-world mile per gallon ratings than cars are, which is important to understand when trying to be competitively viable in the industry. This data exploration leads to the ability to make predictive models. So the predictive model building and outputs are going to use all vehicle types as described before. The response variable, or the variable that we're trying to predict, will be the real-world miles per gallon variable. The inputs will be all the numerical variables in the EPA dataset. So the dataset was subsetted to not include any variable that was categorical in nature, so that the models would have a valid output. And the two models that will be used are multi-linear regression and the time series forecasting models. The evaluation of these models will use a gains chart, which evaluates the output of the model to if random guessing or a naive approach was used, as well as comparing the prediction value between the multilinear regression model and the time series forecasting model to see if the predicted values are within the same scope. The assumptions are that the variables in the dataset are normally distributed. This was explored further in the research project through different descriptive statistical tests and can be found in the research paper. So now that we know what models we'll be building, let's see what the output of the models show. So for the multilinear regression model, we find that the regression model is a statistically significant model at the confidence interval of 95%. So the p-value of the model is less than 0.05, making it a statistically significant model. As you can also see, many of the variables within the model are statistically significant at the set 95% confidence interval. This means that variables such as acceleration and powertrain electrical type and powertrain hybrid type and diesel are statistically significant in areas that Ford would want to focus their resources on in developing, because they have an impact either positively or negatively on the real-world mile per gallon estimates. And this leads into the estimate values. So the estimate value column shows how much the 1 unit increase of a variable would impact the real-world mile per gallon values. So for instance, if we are looking at the acceleration variable, a 1 unit increase in the acceleration variable would decrease your real-world mile per gallon by 0.0013 units. This means that acceleration has a negative effect on real-world mile per gallon. And this statistically significant model, as well as some statistically significant variables within the model, allow us to reject the research null hypothesis, meaning that there are variables that have a statistically significant relationship with the real-world mile per gallon output variable. This is important in knowing, because that means that an analysis can be done and a model can be built to predict the future values of the real-world mile per gallon output variable. This leads us to a graphical representation of the prediction values. So as you can see from the chart on the left, the prediction value chart, the predicted values for gas mileage increase, similar to the chart that we saw previously, where we were just simply graphing the real-world mile per gallon values over time. We can see that predictions are also increasing over time. This model shows that We expect that in 2021 going forward will be around the 24 miles per gallon mark, but it will be increasing over time so that we can build a reliable model for predicting values further into the future. The gains chart shows that the multilinear regression model, performed better than random guessing or the naive approach, meaning that the model is useful in producing predicted values that can be relied on by the organization. Now that we looked at the multilinear regression model, the next model we'll be looking at is a time series forecasting, or ARMA model. This model was also statistically significant, and the results are similar to the regression model. So if we look at the blue line of the time series forecasting model, we can see that the values are close to the 24-25 miles per gallon area for the next couple years, as well as it's trending upward. This shows that the comparison between the two prediction models means that we have statistically significant research done, as well as two models that can be used to predict the future values of the miles per gallon ratings. And these values are useful in determining how Ford Motor Company looks at their products, as well as what they should expect the industry to demand in the future when it comes to miles per gallon ratings. So looking into the future, we can look at the different types of technologies, powertrains, different types of automobile changes. So if we look at hybrid and electric vehicles, which is where the future trends given through the literature review are going towards, we can see that the electrical car, the plug-in hybrid, and the gasoline hybrid on the right side, these charts are increasing over time with no certainty of how much they're increasing or how much they are improving over time, but we can definitely see that there is an improvement over time. And when comparing this to Ford's production percentage of electric, plug-in hybrids, gasoline hybrids, we can see that they are above the industry standard. This means that Ford is putting a lot of time and resources into an area of growth, as well as statistically significant variables given our linear regression model and time series forecasting model. So in focusing and putting resources in these areas is good for the overall increase in the miles per gallon ratings, as well as matching what the demand in the industry currently is and what it plans to be going forward. Based off the research that was conducted, there are a couple recommendations the research team can provide the Ford Motor Company. The first is that the models that are presented in this report can be used both for current and future state. The descriptive and predictive models built should be used for assessing the current state of the industry and where Ford Motor Company falls within the industry, comparing their internal data to what is the external EPA data set and the analysis performed on that. The models should also be used for more of a forward-leaning approach so that they can look at the future state of the industry and see the trend of where the industry is heading and where to focus on resources. Ford Motor Company will also want to include internal data, as stated before, so that they can more accurately compare and provide a more robust model than the one used here. This is a framework for how data analysis should be conducted, so any variables that will be included by the Ford Motor Company will just make a more accurate and useful model for the company. And the model has continual development opportunities. So the EPA dataset that was used for this analysis is continually updated. So values for the prediction of next year or the next couple years can be compared to the model and the actual results that will be contained within the EPA dataset. This data can also be added to the model so that the model can become more accurate going forward. So the model and analysis presented in this research project has provided Ford Motor Company the ability to look at the current trends and future trends in the automobile industry. It has provided a framework for analytical work that can be done on describing the current state in descriptive statistical tests, as well as the future state in predictive statistical tests. These models are robust and are able to predict the future of the automobile industry. And this will provide a competitive advantage in allowing Ford Motor Company to assess their current product lineups, as well as predict how their products should line up with the industry going forward. This will provide a competitive advantage when using or leveraging data to look at the historical aspects as well as the future aspects of the industry. And since the automobile industry is constantly changing, these are agile models that can be used, that can add additional variables or additional data to become even better and more accurate in predicting future values of of the miles per gallon ratings, as well as looking at the economic and different environmental factors that could be changing here and going into the future. I'd like to thank Ford Motor Company for allowing me to present this research project, and I look forward to them using and leveraging these models to provide a competitive advantage in the industry. Thank you.